Welcome to Blender add-on development for beginners. In this module, we are going to develop an add-on that presents graphical overlays. This is a bit beyond beginner level, but so useful I want to present it anyway. The concepts and basic building blocks are not too complicated, but I'm not gonna lie, there are a lot of moving parts here, so it will be hard work. We will be going through the code in detail, and the source is provided on GitHub as usual, so it should be doable. But if not everything is clear at once, you might just install the full add-on and see how it works, and then perhaps tweak a few things to see their effects. Because in my experience, people tend to learn best by doing, so don't hesitate to tinker a bit with the code. Along the way, we will also learn something about controlling the layout of panels and how to add user preferences to an add-on. Let's get started. First, let's discuss what an overlay is. Overlays are things shown on top of objects in the 3D view and are typically controlled from the Viewport Overlays panel. Things like the X and Y axis are examples, but also geometry-related extras like a wireframe on top of the object. Overlays can provide a lot of useful information, so let's talk about what our add-on will do. The idea is that it will show the distances between objects we select. It is an overlay, so it lives in the Viewport Overlay panel. Initially, it will be grayed out because we need to specify between which objects we want the distance to be displayed. So we select each of the icospheres, and back in the Overlay panel, we can then set the selected objects. As soon as we do that, lines and distances are shown between the active object and the other selected objects. And if we move the view around a bit, the lines stay connected to the objects, with the labels halfway, all in the proper camera's perspective. All of this is dynamic too, so when we deselect all but the active object and move it around, the lines and distances are updated with every move. It doesn't matter which object we select as long as they belong to the same set we added previously. If we don't want to see the distances anymore, we can disable the overlay. So this is what we are going to build in this module, and we start by looking at the draw handlers. To draw something on top of the 3D view, we need something that is called a draw handler. This will be called every time something changes in the 3D view, and this handler will do graphics calls on its own. This may sound complicated because of all the different graphics cards and graphics APIs like OpenGL, Metal, Vulkan and whatnot, but luckily this is all abstracted away by Blender in its GPU module and some helper modules, so that everything can be done in Python without having to worry about the actual platform we are on. Graphics cards or GPUs deal with shaders to draw things on screen, but we don't have to supply them ourselves, as Blender provides a few common ones as built-ins, including one to draw a uniformly colored line. We are going to use that shader in a small helper function we define that will draw a line between 2 points, P0 and P1, with a given color and a line width. And here we see in action what I mentioned in the intro of the video. Dealing with those low-level graphics isn't complicated per se, but does require quite a lot of code to configure all kinds of little details. Links to relevant sections of the manual are in the description, but let's try and understand this line by line. First, we create a batch of drawing instructions for the GPU. Here we specify we want to draw lines. And when drawing lines, we need to provide a dictionary with a pos key that points to the list of points. The shader we pass as the first argument will then be used to draw lines between those points. Because we only supply 2 points here, only a single line segment will be drawn, but if needed to draw a lot of lines, we could make things more efficient by providing more points to draw several lines at once. We will draw only a few things, so no need to worry about performance, and optimization is always best left to later anyway. Next, we bind the shader, which will prepare it so that we can configure so-called uniforms, values that are the same for all points, like the color and the line width. We also configure the viewport size, that is, the height and width in pixels of the 3D view area inside the viewport, something that we can get by calling the viewport get function. And finally, we draw everything we configured on screen. This looks like a lot of work for drawing a single line, and it is, but it is reusable. So just for fun, let's define a draw handler that will draw a wireframe cube to illustrate what is possible. We call it draw handler post view, and we explain what post view is when we install the handler in a moment. And a cube has 8 corner vertices that we define here as 3D vectors. As you can see, it's a cube with sides of length 2 and centered on the origin. We also define all 12 edges between those corners, each a tuple of 2 indices. The line color we want to use is defined as RGBA, so here fully opaque, bright red, and we choose a nice large line width. Then all we have to do is loop over each edge and call our drawLine function. We also define a small helper function to mark all areas in all screens as needing a redraw. Strictly speaking, we would only need to redraw the 3D view, but since we only call this function once, we won't complicate things by adding all kinds of logic, and simply mark everything for redraw. Even though we use it once in this example code, we define it as a function, so we can reuse it later in other code. Now let's add some code to test our handler. Draw handlers for the 3D view are added by calling the drawHandler add method on the SpaceView 3D class. We pass it our function and an empty tuple because our function does not need any arguments. We specify a region, and most of the time you will use window to draw on top of the actual 3D view, so not on top of the sidebar or the header or anything. And we specify that this is a post view handler. Now a post view handler is a drawing function that will be called after all the objects are drawn, hence the post, but in camera view, so it knows about perspective and camera rotation and all that. And that is why our drawLine function can work with 3D vectors. As we will see later, there are other options too, and we will see that later when we draw text. When we run the code, nothing seems to happen until we rotate the camera view. But when we do, a 3-dimensional cube is shown. It is always in front of the object, and it does have the correct perspective and follows the camera. If we would have called our redraw function, the cube would have been drawn immediately, because a draw handler is only called when needed, that is, when something changes in a 3D view, and simply running the code and installing it didn't change anything in the 3D view. So we had to move about a bit to trigger that. In the code in the final add-on, we will make sure the call to the redraw function is made. What about text? Well, let's create another handler for that. This will use the BLF module, short for Blender Fonts, along with some utilities provided in BPY Extras. This new handler we will call drawHandler postPixel, and we see why in a minute. The idea is to show a label with an index at each corner, so we need the corners of the cube. We will use font 0, Blender's built-in font, which is always available. A font size of 20 pixels is rather big, but easy to see in a demo video. And for the color of our text, we choose a fully opaque, bright white. And as with drawing lines, drawing text isn't really all that complicated, but again, you do need quite a few lines of code to let it look nice. We want to use drop shadows on our labels, and for that we need to enable alpha shading. We also need to specify that we want drop shadows, and that shadows for font ID 0 are very blurry, black and slightly transparent, and offset a little bit to the lower right. We also specify the font size and color. Now to position the text, we again specify the font ID, and then the X, Y and Z position. This will be relative to the lower left corner of the area we are drawing in, and since all this will be two-dimensional, the Z coordinate can be 0. A draw call is then what is used to show the actual text. And here we start with Hello World for demonstration purposes. We'll change that later. We then define our redraw function and go to install our handler. We use the same drawHandler add method, but this time we specify postPixel. This will cause our handler to be drawn as part of the final layer, and this layer is two-dimensional. And for text, this is what you need, because all text should always squarely face the viewer. And finally, we call the redraw function. So our handler will be called as soon as we install it, even if we don't do anything in a 3D view. And when we click Run Script, we see our text appear immediately on screen. Now that proves that we can show text, but what we really want is labels near the corners of the cube. So let's replace the Hello World code with a loop over all vertices. The vertices have a position in 3D space, so how do we determine where to draw text near that position, but then in a 2D layer? That's where this utility function comes in, provided in Blender's View 3D Utils module. It takes a region, which we retrieve from the context, and in our case will be the 3D view, its associated data, which contain things like the camera perspective, etc., and then the 3D coordinates. It will then return the 2D coordinates, which we can use to position our label. Position takes separate x, y, and z coordinate arguments, so we unpack the x and y coordinates and pass 0 for the z coordinate. And finally, we draw our label, in this case the index of the vertex. We run the script and see what we get. The labels follow the corners as the camera moves, but the labels themselves always face the camera as they should. Also note that Hello World stays on screen because we didn't remove that handler that draws it. It's perfectly fine to install more than one draw handler. So now that we know how to draw lines in 3D and text in 2D, we will see in the next video how we can create a complete add-on that uses these concepts to draw distance line between objects. Thank you for watching and see you in the next one.